Hello students, today we'll study the chapter Force and Laws of Motion, and already we have covered a lot of topics, that different laws of the motion, the three laws of the motion we have already studied. Now in this lecture, whatever we will study, that is the impulse and friction. Okay, so impulse and friction. Now before going to impulse, we again memorizing that momentum. Now, what is momentum? Generally, this term we are using in case of sports, right? Now, when one commentator says that the player has the momentum, it means that the player is actually on the move and it is very difficult to stop him. Okay, so momentum, that means a body that has momentum cannot be stopped, and therefore it is mandatory to apply a force against its direction of motion for a particular period of time. So suppose one person, he is moving in this direction with an uniform velocity. At that time, if you want to stop that person, then you have to apply another external force. Okay, so that means this person, he has momentum, that's why I need to stop him. That means I have to apply a force against its direction of the motion. So if he is moving in this direction, then I have to apply a force. I have to apply a force that is I have to apply the force that is in opposite direction of the motion of the person, right? So this is the momentum. Momentum means the body or the person, he is moving with a momentum, right? And he cannot be stopped until unless if you are applying, some force, but this force direction should be in opposite to the person's movement. Okay, now greater momentum, that means harder to stop. So if a person, he has greater momentum, very high momentum, then you have to apply a very hard force. That means much force you have to apply. So hence higher amount of force is required, and considerable time should be spent to bring the body to a halt position. Now, whenever one person is in very high velocity and he has a momentum, very high momentum, at that time, what it will require, that you have to apply a high force to stop him. But it is not like that. Whenever you are applying the force, just at that instant, the person will stop. It is not like that. It will take some time. So this time, how much time it will take, that depends on the person's momentum. Okay, so if he has a very high momentum, then you require a little bit greater time than the lower momentum person, right? So the force that acts on the body or the person for a given time, the body's velocity changes, hence the body's momentum changes. That I have told you, a person who is moving with a velocity, first actually whatever I have to do, suppose he is moving with uniform velocity, first I have to slow down that person. I am applying the force against its direction. That means I am just trying to change the velocity. Suppose he has the velocity v, now I have to stop him. That means I have to make the velocity 0. But suddenly it is not possible. It will take some time. So here the person's velocity, that will change. Definitely it will change if you are applying the force against him. So the velocity changes. That means the person's momentum also changes. Now the force changes the velocity, whatever you are applying against that person, and if the object's velocity changes, the momentum also changes. Okay, so that means if instantly, if you want to stop, then it is not like that. The object that is in a very high velocity or higher momentum, at that time it will stop instantly. It will take some time, but you have to apply the force against its motion but in opposite direction. So whatever the applied force, it should be in this direction if he is moving in this direction, right? From left to right. So you have to apply the force from right to left. Next, here, sometimes whenever we are seeing one football match, at that time we can see this type of activity. In a football, the defensive player applies a force for a given amount of time to stop the momentum of the offensive player with the ball. So we can see this activity, this type of things in whenever you are watching one football game. At that time, you can see that the defensive player, he will apply some force just to stop the offensive player, right? So here, a change in momentum depends on the force that acts and also the length of the time. That means during how much time you are applying, that is also one factor. Another factor is that how much is the force you are applying to change the momentum, right? And a brief contact by a defensive football player will change the momentum of the offensive player in this case. Now, however, if the same force is applied over a longer time period, a greater change in the momentum will occur. And if same force you are applying during a very high, longer period and time period, then greater change in the momentum will occur. So, impulse that is used to describe or quantify the effect of force acting over time to change the momentum of an object. This you should remember. Impulse, what is impulse? Impulse that is used, this term in physics that is used to describe or quantify the effect of force acting over time to change the momentum of an object. To change the momentum of an object. And it is represented by J. Usually, it is represented by symbol J and usually expressed in Newton second or kg meter per second. Newton second or kg meter per second. That means during how much time you are applying the force, that is also very important here. Next, the impulse and momentum theorem. Here, the impulse and momentum theorem, just a minute, I have to change this one. The impulse momentum theorem states that the change in momentum of an object, equals to the impulses applied to it. Equals the impulse applied to it. So, the change in momentum of an object, that is the delta P. So here I can write delta P, that is change in momentum, okay, and F net, that is the net force you are applying to the object, and delta T, that is the time span, okay, and J, that is the movement. Sorry, just a minute. Just a minute. That is the impulse. Okay. So here delta P, that is the change in momentum. F net, that is the net force. Delta T, that is the during which time, that means the time interval during which you are applying the force, right? So impulse is the J, that means impulse is the change in the momentum of an object that equals to impulse. So J equals to, here we can write J equals to delta P. That means impulse equal to, that is the change in momentum, or change in momentum of an object that equals the impulse applied to it. And the impulse applied to it is how much? You are applying the force, that is the net force, during what interval of the time? That is the delta t. So this is the impulse momentum theorem. Next, impulse equation, that already we have said. In this equation, the impulse is the product of what? The net force and the acts on the object. The net force acts on the object for a certain duration. Here delta t, that is the duration, already I have written in the last slide. And F net, that is the net force you are applying to the object. You are applying to the object. So the impulse, that is the product of average net force and that thing that acts on the object, and what? The time duration. The time duration. Okay. And impulse is a vector quantity like force, and it also has the direction. Okay. This is a vector quantity. And here, that's why it is a vector quantity. That's why we are using this arrow mark to represent the J. And this J, already we know that from the impulse momentum theorem, that this J is nothing but, this J vector, that is nothing but delta P. That means change in the momentum. So the impulse J, that is the P2 minus of P1, where P2 is the initial momentum, P2 is the initial momentum, and P1 is the final momentum. So the change in the momentum, delta P, where delta P equals to P2 final momentum minus initial momentum, P2 minus P1. So the impulse equals to our change in momentum. We know that from the impulse momentum theorem. And what is the delta P? That is the P2 minus P1, final momentum minus initial momentum. So with this formula, we can equate a lot of numericals, right? So this is the relation between the impulse and the momentum. Now, impulse example, already we can see whenever you are watching the cricket match, the cricket player, whenever he has to catch one ball, at that time, he lowers his hand just before catching the ball. Why? There is a reason, and the main reason behind this, that is the impulse. So whenever he is lowering his hand to catch the ball, this increases the time of impact and decreases the effect of force. So that's why it will be easy for him to catch the ball, right? Because the ball, it has a very high amount of momentum. Okay, its velocity is very high. Whenever some batsman, he is just throwing this ball. So at that time, you can see that if you want to catch the ball, you have to lower your hand, and this you are doing because this much of time you require to catch the ball. So here this increases the time of impact and decreases the effect of the force. That's why whenever a fielder that pulls his hand gradually with the moving ball while holding a catch, right? So the fielder, he pulls his hands gradually with the moving ball while holding a catch. That means the main thing, that is with the fielder, he has to increase the time of impact to reduce the effect of the force. Until unless you can see that if he will catch, if he will not extend the time of impact, he will catch the ball, then the force is so high that it can harm, it will be harmful for him. Now, this already, if you have any siblings or your little brother, little sister, at that time you can see this might be happen. So here, when someone falls from the bed on the floor and receives some injuries, but if you are just you are trying to fall on the sand, heap of the sand, at that time you can see that your injury is not there. Okay, or a very little bit injury is there. Why? This happens because the sand is more than the cemented floor. Therefore, this will increase the impact time and lowers the impact of the force. Okay, that's why whenever one person or one child he just falls from the bed on the floor, cement floor, at that time very high injuries will be there. But whenever you are playing with the heap of sand, that means you are jumping on it, at that time you can see that your injuries were not there, or you are not receiving any injury. Okay, now here one question, let's solve this one. The object weighs 3 kg. Just a minute, I have to change the ink. Okay, let's solve this one. The object weighs 3 kg. So first, mass M, that is 3 kg, fine. And the velocity has a velocity of 5 meter per second before colliding the object. So if the velocity before collision, that is V1, 5 meter per second. So velocity after collision, V2, that equals to 0 meter per second. Now they have asked to find out the impulse, and you know that with the impulse there is a relationship between impulse and momentum. So the change in momentum, that is delta P, that equals to M into V2 minus M into V1. P2 minus P1, right? P2 is the M into V2 and P1 is the M into V1. So here, if we put the value of M, V2 and V1, then we can find out that delta P, that equals to our 3 into 0, and this will be 3 into 5. So this will be minus 15 kg meter per second, right? So here the change in the momentum, now the impulse, this is nothing but delta P, right? Change in the momentum. Now, and the impulse that equals to delta P, that's why the impulse will be our 15 kg meter per second. Okay, 15 kg meter per second. Now, this type of questions may come. Define impulse. So impulse of a force is defined as the product of average force and time interval for which the force acts on the body. So here the impulse, you can write the equation also, that is F net into delta T. Okay. What is the unit of impulse? Newton second. What is the relationship between impulse and momentum? Just now, whenever we are solving the previous problem, at that time we have used this one. Impulse is equal to the change in linear momentum of the body. Okay. Or J, you know that equals to change in momentum. Now the friction. Now friction is defined as a force that opposes the motion of the solid object over another. Now you know that if you want to move, just a minute, I'm changing the ink color. If you are walking, you are facing some frictional force, because if you are walking in this direction, you can see that some frictional force frictional force will act against your position. If you are moving any object, at that time also some frictional force are acting on the body or the object. So friction is what? Friction is one type of force, or friction is defined as a force that opposes the motion of the solid object over another. That means if you have this surface and if you have one block here, and this block cannot move over this plane because of the frictional force offered by this plane, right? So there are mainly four types of the friction: static friction, sliding friction, rolling friction, fluid friction. Okay, and you know that if this is the object and if this is your fluid, then this is the fluid friction and this is the direction of motion. If you have static object on a plane, at that time you can see that there will be no motion. There is a static friction acting at the surface of the where it has the contact. The block has the contact with the surface of the plane, right? Sliding friction, whenever we are going to slide this object, at that time you can see that some sliding friction it will offer. Rolling friction, sometimes we are rolling some wood, or we can roll any gas cylinder also. At that time rolling friction will be acted. So yeah, I will describe all these frictions elaborately. Before that, the friction, first you have to know friction and normal force are directly proportional to the conducting surface, and it does not depend on the hardness of the conducting surface. So the frictional force F of friction, that equals to mu into N, where N is the normal force. Now let me explain what is normal force. Suppose this is the plane, okay, and or ground, and you have one object over this. So here there will be some normal force acting on this object. So this is the normal force. Okay, this is the normal force, and coefficient of friction, that is the coefficient of friction that depends on the surface, and frictional force that equals to mu into N, where this normal force that depends on the mass, and here if you have the gravity, then m into g or m into a. Okay, so here the friction and the normal force are directly proportional to the conducting surfaces, and it does not depend on the hardness of the conducting surface. So friction, here with the increase in relative speed, sliding friction reduces. Now if you have a car and you can see that some wheels are there and it has a very high speed at that time, how this can happen? Whenever the sliding friction, whatever offered, that is reduces. That means that's why you can see that whenever we are just pushing any object in with respect to that, if you are rolling the object, that will be easier. That will be easier. Suppose you have one gas cylinder and you are just pushing this gas cylinder to move from one place to another place. So here, suppose you have some gas cylinder here. Some gas cylinder here. Okay, some gas cylinder here, and you are trying to push this one. So here you have very hard to move this gas cylinder. You very hard to move this gas cylinder. Okay, so if you are rolling this one, at that time you can see that if you are rolling on the floor, at that time you can see that the sliding friction reduces and it's easy to move that object or move the gas cylinder. So fluid friction increases with the increase of relative speed. And whenever you are just rowing one boat, at that time you can see that the fluid friction that increases with the increase of relative speed. Fluid friction is dependent on the viscosity of the fluid. Viscosity. Viscosity is what? Viscosity is the resistance, how much offered by your water. So the viscosity of the fluid, I can write here, the viscosity of a fluid, any fluid, it may be water, is a measure of its resistance to deformation at a given rate. Deformation at a given rate. So here, one example I can give, that syrup, it may be syrup of sugar or any syrup of any squash also, has a higher viscosity than water. Okay. So the viscosity is what? The viscosity of a fluid is a measure of its resistance to deformation at a given rate. Now here, any type of syrup that has higher viscosity than water. Water has less viscosity. So here you can see that the fluid friction that is dependent on the viscosity of the fluid. That's why the fluid friction also depends on the type of the fluid. It is water or it is syrup or it is oily, some oil, anything else. Okay. Now the sliding friction here, each point on the body has only translational or linear momentum. So if I think about B position, now here sliding friction, in this case you can see that this B position will be changed. That means it will change the position. Whenever it will slide, you can see that this B will move in this here, then this position will come touch the ground like that. But in case of rolling motion, different points have a combination of linear as well as rotational motion. And you can see that whenever we are using car here car wheel, you can see that the car wheel, it will rotate with a fixed point. Okay. So if you have a car wheel or cycle wheel, whatever. So if you have a cycle wheel or car wheel, whatever, this will move with a fixed point. Also, if you have a ground here, on this the wheel will move. At that time you can see that it has some linear movement or it has some translational motion also, right? Now here you can see that in this friction, if we consider only the rotational motion, the point B tends to move backward. Suppose with a velocity VR, okay. So here you have the point B. Now suppose there is rotational motion, only we are considering. So it will move backward with a VR, okay, with the velocity VR. Now we consider only linear motion, then point B moves with the velocity VL, in the forward direction. So now resultant motion of the point B will be the superposition of both the above velocity. That means one, here you have two motion. One is that due to the rotational motion, you have a velocity VR, that B point will move backward in this way, and VL, this is a velocity where point B has the linear motion and it will move forward, right? So here, what will be the actual motion you have or the resultant motion you have? That is the superposition of these two. That means the combination of these two velocities. Now here you can see that whatever the values of VR and VL, the rolling friction can act on the following direction. Suppose first condition, this is case 1. Okay, let it be case 1. If VR is greater than VL, that means rotational velocity that is greater than the linear velocity. At that time, point B tends to move backward. So as we know that friction opposes relative motion between the surfaces in contact, hence it will act in the forward direction, right? So if VR is greater than VL, VR is greater than VL. Next, if VR is less than VL, that means what? The velocity due to the rotational motion that is less than the velocity due to the linear motion. So at that time, point B, it tends to move forward, hence the friction acts in the backward direction. So you know that if it will move forward at that time, the frictional force, it will act in the backward direction, right? If it will move forward, then it will act in the backward direction. Now suppose this is case 2. Another case may happen, that is the case 3, that is VR equals to VL. That means the velocity for rotational motion that equals to velocity for linear motion. At that time the ball moves in the forward direction, the frictional force acting on the ball will be 0. So this is unlike sliding friction. Okay. Thank you. Next, we'll elaborate all these types of frictions. Till now, up to